Open your book to page 935. Today's lesson is to find limits at the infinity. On page 935, you have the limit of x squared minus 1 of x squared plus 1 as x approach to infinity. So whenever you're looking for the limit as x approach infinity, it's same as looking for the horizontal asymptote, because when you have the function at infinity, when x equals infinity, it will be limited by the horizontal asymptotes. So if you look at this over here, look at this equation over here. So that is your function. And again, you go through the steps, right? First, you look for vertical asymptote. That's no vertical asymptote. Then you look for horizontal asymptote. Horizontal asymptote determined by the highest degree term. So the minus 1 and plus 1 would be insignificant. So you're going to have x squared over x squared, therefore it's equal to 1. So your horizontal asymptote is y equal to 1. And then you can get so you can factor the top to get the x-intercept, right? X plus 1, x minus 1. So you got plus 1, minus 1 as your intercept, right? And the y-intercept, you set this equal to 0, and you solve. So you're going to get negative 1 over 1. So again, y-intercept is when you set x equal to 0, so you got negative 1 over 1. So that's your y-intercept. So you sketch it out. So the graph for this function is the blue line. And the red line is your asymptote. And so when you have these, when x approaches infinity, right? When x approaches infinity, it will be limited by the horizontal asymptote. So again, so basically, when you're taking the limit as x approach infinity, you're looking for the asymptote at this side over here. Now, if you go to negative infinity, you're looking for the horizontal asymptote on this side. Okay? So again, your limit when x approach infinity is limited by the horizontal asymptote. Now let's go to example 1. So on page 937, example 1, you're looking for the limit of 1 over x as x approaches infinity. So notice the numerator has 0 degree and the denominator is 1 degree. So if you figure out a horizontal asymptote, would be y equal to 0. So therefore this is equal to 0. Okay. And let's go to example 2. On page 938, example 2, you're looking for limit of 3x squared minus x minus 2 over 5x squared plus 4x plus 1 as x approach to infinity. So again, as x approach infinity, the lower degree term would become insignificant compared to the highest degree. So all this would be insignificant. So you can just ignore that. So basically, you have 3x squared over 5x squared. So when you reduce, this will cancel out. So this will equal to 3 over 5. So in other words, the horizontal asymptote is y equal to 3 over 5, and that would be your limit. So this is equal to 3 over 5. Okay. So again, the limit as x approach infinity is limited by the horizontal asymptote. Okay, so let's go to example 3. So you have the limit of e to the x as x approach to negative infinity. So this one is not as obvious because this is not a polynomial function. Therefore, it's kind of it's more difficult to find out where the horizontal asymptote is. But if you were to graph it out, if you were to graph these things out, it looks like this. So your horizontal asymptote is y equal to 0. So therefore, when it approaches to negative infinity, this will equal to 0. Okay. So again, if you don't know what a function looks like, or if you have a hard time, just plot the points and make a table, and you can look at the table and figure out the limit. Let's go to page 939 and look at example 4. You have the limit of sine of x as x approach to infinity. Now for this one, if you look at the sine graph, so this is the sine graph. Notice it oscillates, so it doesn't stay at one value. So in this case, the limit does not exist. Okay, so it does not exist. So this one again. So you kind of have to look at the graph. Okay. So this one does not exist. Okay, now let's go to example 5. So you're looking for the limit of n over n plus 1 as x approach to infinity. Again, if you look at these, again, horizontal asymptote would be n over n, so equal to 1. So in this case, it will approach to 1. Okay. Now sometimes you will have a graph. So if you look at this graph over here, like number 2, okay. So in this case, if approach infinity, so when x approach infinity, the y will approaches to 1, 2, 3. So the answer for this side would be approach to 3. Whereas if it go to, so the part 1, this will equal to 3 because it approaches to 3. The part 2 of it approach negative infinity. So when x approach negative infinity, the y will approach to negative 2. So again, horizontal asymptote over here is 3. The horizontal asymptote on this side, on the negative infinity part, is going to be equal to negative 2. Okay. So again, you can look at graph and you can look at some of the, able to figure out the answer.